And we're back to part 3 of hypothesis testing for correlation. We remember that we want to check to see that we have bivariate data on a random sample of that, and to check to see that the scatter plot looks somewhat like a line. That's a stand-in for that the x is normally distributed for fixed values of y, and y is normally distributed for fixed values of x. And then if we have outliers that are known to be errors, we take them out. Otherwise, we leave them in. Okay. So let's use a 5% level of significance to test the claim that there is a linear correlation between the number of people in the county, measured in thousands, and the number of crimes. Well, first off, we had a random sample of counties. Okay. Our scatter plot looked pretty close to a line. Okay. And we didn't seem to have any outliers that we knew to be errors. So we've got our 3 conditions there. So let's write out our hypotheses. Again, our default assumption is that there's no correlation until we have evidence otherwise. And in this case, it just checked for linear correlation. It didn't say positive linear correlation. It didn't say negative linear correlation. It just said linear correlation. So it could have been positive or negative. So this is going to be a not equals to and be a two-tailed test. And we remember that our level of significance is 0.05. Okay. Now you can do it traditional way and you can do it p-value way, but either way, let's go ahead and use the calculator to help us on this. So grab your calculator and remember how we had the number of people measured in thousands in the list 1 and the number of crimes in list 2. Okay, we're now going to go to stats. We want to do a test, and we want to do a linear regression t-test. T because we don't know the population standard deviation. Okay, and so linreg t-test. It's going to ask us where our x data is, and it defaults to list 1. Our y data defaults to list 2. We'll leave those, and we'll leave frequencies at 1. And what does our alternate hypothesis look like? It was rho is not equal to 0. Okay. And if you want, you can store the regression equation, but for right now, I'm just going to go ahead and hit calculate and see what it comes up with. Wow, check this out. We get lots of good stuff that I want you to write down here. So let's move this up so we can see this. We find out that t equals 9.93, p equals 6.03, df equals 6, a equals negative 72.87, b equals 25.82, and all kinds of good stuff. It even gives us r and r squared again. R equals 0.971, and r squared is 0.943, rounded to 3 decimal places. Now, I hope you noticed something, and I made a mistake on purpose here. The p-value, remember, p-value is probability value, and it can never be more than 1. So when it says 6.0, keep reading for the scientific notation, e to the negative 5th. So this is 6.03 times 10 to the negative 5th. That means this is going to be a teeny tiny number, namely 0.0000603. So we've got this guy. You could, if you wanted to do this traditional way, we know the degrees of freedom is 6, and this is a two-tailed test. So we could pull out our t-table. So 6 degrees of freedom on 2 tails, and 5% in 2 tails, 6 degrees of freedom. So our critical values would be t-scores of plus and minus 2.447. So t sub c equals 2.447, and t sub c equals negative 2.447. So here are our critical regions where we will reject H naught. And where did our test statistic land? Wow, way out here at almost 10, 9.93. So we would definitely reject H naught. Therefore, we have enough evidence to say that there is a linear correlation, that it's not the fact that there's no correlation. Okay. All right. Okay. Now we could also do it the p-value way. So like we've learned before, we could take our p-value, which was 0.000603, and if we compare that against alpha of 0.05, we see that our p-value is much smaller. So we will conclude to reject H naught, meaning there is enough evidence to conclude there is a linear correlation between the number of people in the county and the number of crimes. Okay. All right. So a good conclusion like that, reject H naught and then tell us what that means. Now, again, we say that we didn't prove that there's a linear correlation, but just that there's very strong evidence that there is. And two last things here. The first of the last things here is just because there's a correlation between two variables, they both move together, or they move as one goes up, the other one goes down. Just because there's a correlation between the two variables does not mean one causes the other. So it doesn't mean that the number of people in the county causes the number of crimes. We often state this as correlation is not the same as causation. There may be another factor that's influencing both variables. One of the hallmark examples is if you take a look at ice cream sales and crime. So ice cream sales and crime. I know I'm going to do a bad graph, but it tends to look like this. And so you might think, wow, in fact, they've done studies that there is a positive linear correlation between ice cream sales and number of crimes. Okay, but that doesn't mean that ice cream causes crime. Okay, maybe your brother or sister eats your ice cream and you want to kill him or her, but that's really not what we mean here. So there may be something that's causing both of them to change. And as it turns out, there's a lurking variable here called temperature. As temperature goes up, ice cream sales tends to go up, but so does the number of crimes. So you see that even though these two things are correlated, there's somebody else that's actually being more directly related to the increase in each of these guys. So again, correlation is not the same as causation. Increases in ice cream sales does not cause an increase in the number of crimes. Okay. So finally here, I'd like you to look at an example on your own. So kind of take it from the top, what we've learned here. I was jonesing for a convertible car, and I did some research on kellybluebook.com and found some Mazda Miatas, because that's what teachers might be able to afford. And I found how much the used cars have been driven and how much the used cars correspondingly cost. And so I want you to make a scatter plot of the data, use a 1% level of significance to test if there is a linear correlation between the miles driven and the cost. And then I want you to find R and then interpret R squared. Okay. So we'll pick you up in the next video, which will be our last section together.